Hi guys, my name's Earth and I'm a rising senior in high school who loves to code. I'm a student at Juni Learning and I'm interning there over the summer. I started at Juni Learning barely knowing how to code, and I did the AP Computer Science track, and since then I've learned so much, doing UC and web development. Today we're going to be continuing making our Tic Tac Toe game, doing an extension by making our Tic Tac Toe game work for any size board, not just 3x3. It is pretty challenging, but I know you can do it. If you haven't already, be sure to watch our first video on Tic Tac Toe where we explained how to do all of the code I have on my screen right now. Without further ado, let's get started. To make our Tic Tac Toe game work for any size board, let's first create a variable that stores the size of our Tic Tac Toe board. Then, change the nested for loops both in our main method and in our other functions so that they iterate the correct number of times, instead of just 3 times. Change the conditions that check if our row and call are out of bounds. And finally, rewrite the function that checks for a winner to make it work for any board size. And this is the most challenging step. The first thing we want to do is we want to make a variable that represents the size of our board. Let's call this variable n, and it'll be an int. For now, let's set it to 4. Next, instead of doing 3x3 in our board, let's make it n by n. Now what we need to do is in all of the for loops we have in our main method, instead of making them I is less than 3 or j is less than 3, we need to change the 3 to an n. And over here, in the print statements where we ask them to enter a row, it isn't necessarily 0, 1, or 2 anymore, so we can delete that. Also, when we're checking if the row and call are valid, we have to check yes if they are negative, but now it isn't that if they're greater than 2, it has to be that if they're greater than or equal to n, or greater than n minus 1. When we had a 3x3 board, we check if it's greater than 2, and if we have an n by n board, we have to check if they're greater than n minus 1. Or we can simply check if they're greater than or equal to n. The next thing we need to do is we need to adjust our has1 function. So let's scroll down to our function. Oh, actually, before we do that, in our other functions, we also use 3 in the for loop. But instead, we have to use board.length and board at I.length. We can't use n since n is only available in our main method. Let's do the same thing for our has_tied. Board.length, which represents the rows, and board at I.length, which represents the columns. Awesome. And now for our has1 function. We're going to need to rewrite our whole has1 function so it doesn't depend on the size of our board. So I'm actually just going to delete all of the code we wrote, and we can start from scratch. Let's start by checking the row. Now what we need to do is the general way we're going to check rows, columns, and diagonals is we're going to have to create a boolean that is true if you have n characters in a row or a column or a diagonal that you're checking. We're also going to create a variable called a value, which is going to store one of the positions on the row or column or diagonal that we are checking. And then we're going to check if value equals a dash. Then we automatically know that our boolean is going to be false, meaning that we don't have n characters in a row or column. This was the same thing we were doing when we checked if one of the values was a dash, because we don't want to check if we have n dashes in a row. We only want to check if we have n x's or n o's in a row. If we don't have a dash in value, we can loop through all the other positions on the row or column or diagonal that we're checking. And we can check if a position doesn't equal the value, then we can set our Boolean to false and break out of the loop. If our position doesn't equal value, we know that we don't have n in a row, and that's why we can set it to false and break. And then outside of the loop, we use a conditional to check if the Boolean is still true, we can return value, which is the winning character. And otherwise, we won't return anything. So for row, let's first start by making our Boolean called in a row equals true. Then let's make our value. We can say car value equals 4.00. Actually, before making our value and our in a row, what we need to first do is, since there are multiple rows, we need to loop through each row. And how we can do this is using a for loop. For int I equals 0, I is less than, for dot length, I plus plus. And now we can make our Boolean and our value. Because remember, we aren't just checking one row, but we have to check each row. So now, instead of saying board at 0, 0, we can say board at I0 will be our value. Next, we have to check if value is equal to a dash. If value equals a dash, then we can set in a row to false. Else, now what we need to do is we need to loop through all the other positions in a row and check if they're equal to value or not. For int j equals 1, and I'm setting it to 1, not 0, because our value already has column 0, so there's no point in checking if our value board at I equals 0 equals value, because we know that's always going to be true. So for int j equals 1, j is less than board at I dot length j plus plus. Now what we need to check is if board at I j doesn't equal the value, we can set our Boolean in a row to false, and we can break. And we do the break so that we break out of this for loop, the inner for loop. So because we don't need to check every other position once we know that one of them isn't equal to value, because then we know that we don't have n in a row. Finally, outside of this inner for loop, we have to check if our Boolean in a row equals true. Actually, sorry, my mistake. We actually want this if loop to be outside this else statement, outside of the conditional that we had right here. This is because if value is equal to a dash, in a row is false, and then we'll go here and check if in a row is true, and it isn't. So it is going to be, again, right outside of this if else block. So if in a row is true, we know that we've won, and then we can return value, which is our winning character. Awesome. So this whole chunk of code checks each row, and then we have a Boolean to represent, if we have n in a row, a value that we're going to use to check every other value in that row I against, to see if we still have an in a row. And if we find a value in our row I that isn't equal to value, then we can say it's false. And also, we first have to check if value doesn't equal a dash, because we don't want to be checking if we have n dashes in a row. We can use the exact same structure for column. Let's say for int j equals 0, j is less than board at 0.length j++, looping through each column now instead of each row. Inside this outer for loop, let's make our boolean in a call equals true. Let's make our value, car value equals board at, you can say 0j, or we're inverting it since we have column j, and then we'll start at position 0 in the row. And then we have to check if the value equals a dash. Then we can set in a call equal to false. Otherwise, we can loop through each position in that column for int I equals 1, I is less than board.length, I++. And then we can check if board.ij doesn't equal our value. We can set our boolean in a call to false and break, because we don't need to check any other position once we know that one of them doesn't equal value. And again, right outside this else statement, we can say if in a call return value. Awesome. Now that we've done row and call, let's do our diagonals. What we need to do for the diagonals is we need to consider both diagonals. For the first diagonal, we'll start with the top left to bottom right, and we know that their positions are 0, 0, 1, 1, 2, 2, and so on. So what we can do is we can loop through where I represents a position where I represents one of the indexes, and we know that the position on the diagonal is going to be board at I, since the row and column are equal in that diagonal. So for our first diagonal, what we're going to do is we're going to have a boolean in diag1 equals true, and we're going to have our value, car value equals board at, we'll just start at 0, 0. And then we can say for int I equals 1. We'll start at 1 since we have 0, 0 in our value. I is less than board.length, I++. And now we know that the value in our diagonal is going to be board at I. Remember, because we have 0, 0, 1, 1, 2, 2, and so on. We can say if board at I doesn't equal our value, which is board at 0, 0, then we can set in diag1 equal to false. We can break. And then what we can do is outside of this for loop, we can say if in diag1 return value. There's one thing I forgot to do, which is right after we make value, we have to check if value doesn't equal a dash. Equals a dash. And we can set in diag1 equal to false. And then otherwise, we do our for loop. Because remember, we don't want to check if we have dashes in that diagonal. Now let's try to attempt doing the second diag. This is a bit harder. If we think about it, our diagonal is going to start at, over here for a 3 by 3, it's 0, 2, 1, 1, 2, 0. So we can have a for loop, the same as we had for our first diag, to loop through each I, and then that I is going to represent the row, and then the column is going to be our n, which is our board length, minus I, minus 1. If you don't get that, I'll explain a bit later. But first, let's make our boolean and our value. In diag2 equals true, our value equals board at. Okay, so our value, it's going to be, we can have our row be 0, and our column is going to be, if you think about it, in an n by n board, if we want to get to the top right, we're going to need 0 and then the top right index column, which is going to be n minus 1, or n would be board at 0 dot length minus 1. So this is board at 0 dot length is the number of columns, and we subtract 1 because remember, since indexing starts at 0, and if say we have a 3 by 3 board at 0 dot length is 3, subtract 1 and you get 2. So 0, 2 represents our top right corner, and that works for any size board. And we're going to be using the same concept to do our for loop. But first, let's check if value equals a dash, in diag 2 equals false. Otherwise, let's do a for loop. For int I equals 1, I is less than board dot length, I plus plus, the same as we did for diag 1. I is going to represent the row of our position on the diagonal. So we can say if board at I, and then for our column, we want to do the same thing as we did here. What we'll do is we'll do a board at 0 dot length minus 1 minus I. So if we're at I equals 1 in a 3 by 3 board at 0 dot length is 3, minus 1 is 2, minus I, which is 1, and then you get 1. So you get board at 1, 1, which is in the middle, which is in our diagonal. And this works for any size board. If that doesn't equal our value, we can say in diag 2 equals false and break. And then outside of this else statement, we can check if in diag 2, and then we can return our value. And then otherwise, after all of this, nobody has won. Because if we haven't returned anything and we get to this point in our function, we know that nobody is won. So we can simply return a dash like we did before. Now that we've done our has won function, we can try running our code and see if it works for a 4 by 4 board. Because remember, we set n equals to 4 at the top. And it looks like we have an error. It says, going back to our has won function, we have our character value over here, and we also have it over here. And that's conflicting because we've already defined value up here, and because we're using the same name, we think they're the exact same. We can simply fix this by calling this value 1, and calling this value 2. Now let's try running. I'll enter my name, and John Doe. We get a 4 by 4 board of dashes. Nice. Let me try entering 0, 0, and get that top corner. John Doe can enter 0, 1. I can enter 2, 2. John Doe can enter 0, 3. I can enter 1, 1. John Doe can enter 3, 1. And I can enter 3, 3. And as you can see, it shows the final state of the board and it says that I've won. And we can see that I have 4 X's in that main diagonal. And this is great. We have Tic Tac Toe working for our 4 by 4 board, and it also works for 5 by 5 and so on. Nice job, guys. Thanks for watching this video, and I hope you had fun making this Tic Tac Toe extension with me. I know it was pretty challenging, but I hope you guys got it. We post coding and math tutorials like this one every week for different coding languages and experience levels. Subscribe to never miss a video, or click to continue watching our other tutorials. You can also check out our private and group coding and math courses at junilearning.com. See you next time!